In the spectrum of hydrogen, the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series is. Okay. Here we know that the wavelength of the spectrum line in the Lyman series is given by wavelength of a spectral line in Lyman series is, we can write it as 1 by lambda L, that is equal to R into 1 by L square minus 1 by N square, where N is, when N is equal to, we can write it as 2, 3, 4 and so on. And similarly for the Balmer series, we can write this one as 1 divided by lambda B is equal to R times 1 by 2 square minus 1 by N square, where N value in the Balmer series is 3, 4 and 5 and so on. Now for the longest wavelength in the Lyman series, N is equal to 2. So we can substitute the value of the 2. Then lambda L is equal to 4 divided by 3 times R. And for the Balmer series, the longest wavelength is N is equal to 3. By substituting this one, we get the value lambda B is equal to 36 divided by 5R. Then we can write it as the ratio, we can find this one as lambda L divided by lambda B. By substituting the values, 4 divided by 3R divided by 336 divided by 5R, we get the value 4 by 3R into, in the reciprocal format, 5R by 36. If we get cancel R, then this becomes 20 by 108. By simplifying with the help of the cancel of the table 4, then 5 by 27. So option A is the right answer.